The way that we test for the different kinds of possible cations existing in an unknown solution is basically to add either 1, sodium hydroxide, which is a strong alkali to it, or 2, to add aqueous ammonia. The way to add these two reagents to unknown solutions to check and to confirm the kind of cations existing in those unknown solutions is a very special technique. The first step is to drop in 2 to 3 drops of either reagent into the unknown solution and observe. What you are looking for is actually the appearance of PPT. If the PPT should arise, then the color of the PPT. Step 2 is with the existing PPT. What you do is now you will obtain a whole dropper full of the reagent that we are talking about, either sodium hydroxide or aqueous ammonia, whole dropper full, and squeeze it all into the mixture of PPT all at the same time. So this second step is actually what we call adding the reagent in excess. Our intention is to see how the PPT actually behaves in the presence of all that excess reagent, and we will report it whether the PPT dissolves in the excess of the reagent or it does not, and hence it just remains there. If you can still recall, in my previous video, we talked about colored ions, which will be the copper 2 plus ions, the iron 2 plus ions, and the iron 3 plus ions. Let's start with these three first. What if you have been given a blue color solution or a blue-green color solution, and you can say that probably it might contain copper 2 ions, but you can't be sure? What do? We now do the experiment with sodium hydroxide first. 2 drops of sodium hydroxide into the unknown. What you should observe is the presence of light blue PPT, or light blue PPT is produced. Then you drop in the whole dropper full, in excess this time, to that mixture, and what you should see is, for sodium hydroxide, that the blue PPT now actually increases in amount and remains in the test tube. Your observation will be that the blue PPT is insoluble in excess of sodium hydroxide. So that's the first experiment. Then you get a fresh sample of your unknown, again your blue solution. Now you do the same with aqueous ammonia. 2 drops of aqueous ammonia. What you will see is light blue PPT produced again. And this time, next step will be the whole dropper full of aqueous ammonia. You add it to the unknown. What will you get? You will get the light blue PPT dissolving in the excess aqueous ammonia. And when the light blue PPT dissolves, it actually forms a very dark blue solution. It's very outstanding. It's very obvious. In fact, if you take the test tube and you shake it, the entire test tube will now turn out dark blue. This is a very special thing. If you should observe it, then you can very confidently conclude that yes, this unknown solution contains copper 2 plus ions. What if we have been given a green solution and you suspect it may contain iron 2 ions? Then what do? You repeat these 2 experiments again, first with sodium hydroxide and next with aqueous ammonia. Both these experiments for iron 2 would give you exactly the same outcome, which is first 2 drops, you will get green PPT. Now, this green PPT is not a very nice green. It's kind of like brown-green kind of color. It's a green PPT produced, and when you add the reagent in excess, the green PPT is insoluble in excess of the reagent. So you will get plenty of the brown-green PPT. If that's the case, you can conclude that the solution probably contains iron 2 ions. Okay. Then thirdly, if you have been given a yellow solution and you suspect maybe that was iron 3 ions inside there, then what you do is, again, with the 2 reagents, sodium hydroxide and aqueous ammonia, first you add 2 drops, and for both reagents, when you add 2 drops, you will notice the appearance and the production of red-brown PPT, looking exactly like rust. And in fact, if you take a whiff, it actually smells like rust as well. And next, you add the 2 reagents in excess, and you will find that the red-brown PPT is actually insoluble in excess of both reagents. Hence, if that's the case, you can conclude that the unknown solution probably contains iron 3 ions. So for the colored ions, this is the range of observations you should get. Now, of course, if you like what I've just told you and you think you've learned something from it, please click the like and subscribe to my channel. Next video, I will be talking about what happens if you should test a colorless solution, and we can use that to conclude what possible cations could be in there. I got my head out the sunroof, I'm blasting our favorite tunes. I only got one